So we had identities that took, these are products, and we took sums, made them products. These take products and make into sums. And these ones actually do come up in Calculus 2, but it's one sort of very specific topic. So if you take Calculus 2, you might see them again. I don't expect that anybody has them memorized in those classes. So here is where they come from. I'm going to show where the first one comes from. You use the fact that sine of x plus y is equal to sine x cosine y plus cosine x sine y. That's from section 7.2, which was yesterday. Don't have to have memorized, but that's a form of an identity. And then the fact that sine of x minus y from yesterday is equal to sine x cosine y minus cosine x sine y. So both of those are from section 7.2. Notice how in this first identity I have sine x plus y and sine x minus y added together. So if I take sine of x plus y and I add sine of x minus y, because these two things on the left are equal, if I add them, it's going to be the same as adding the things on the right together. Does that make sense? And why is that useful? What happens if you add these things on the right? The cosine x sine y, that bit cancels, doesn't it? So you end up with, how many sine x cosine y's? 2. So 2 sine x cosine y is equal to that sum, right? And so how do you get the sine x cosine y by itself? Not by 2, or multiply by half. So 1/2 sine of x plus y plus sine of x minus y. That's equal to sine x cosine y. And you prove the others pretty much the same way. Just take the identities that involve cosines instead. Does that make sense? And in this case, you may have to subtract them, but add them or subtract them and you'll get something that gives you a new identity. Okay? But the point is what these things do is they take products and they make them sums. Does that idea make sense? And for certain things you do in calculus, that's very useful because it makes something called integration a bit easier. So this is probably something I would ask you to do on a test, but I would give you the formulas. So I'll give you something like this, and I'll say, write it as a sum. So of the list you have above, we think about them as number 1, number 2, or number 3. Which formula is this? It's number 1. Now the one slightly tricky thing is in the formula that I gave you, the sine is first and the cosine is second. And the order does matter a little bit, so I'll write it down. Sine of x cosine of y is equal to 1/2 sine of x plus y plus sine of x minus y. Your book actually spells out a formula if cosine is first and sine is second, but I think that's stupid because I think you should be able to figure out that cosine of 3t times sine of t is the same thing as sine of t times cosine of 3t, and then apply the formula. Does that make sense? And I could be mistaken that this does actually matter, but the reason is that y, or you could know that y is the thing in the cosine. Does that make sense? And x is the thing in the sine. And it won't matter for this first term, but for the second term, you might be off by a negative sign if you don't observe that. Does that make sense? So the important thing for the derivation of the identity is that y is the angle in cosine, x is the angle in the sine. Okay, so then just plug your stuff in. This will equal 1/2. So what goes in for x? And what goes in for y? 3t. So this will be sine of t plus 3t plus sine of t minus 3t, right? So that's 1/2 sine of 4t plus sine of negative 2t. You can do one more thing. Sine is an odd function, right? Which means that what can happen with negatives?
You can turn the positive into just subtraction.
You can take the negative out and make that plus into a minus. So that's 1/2 sine of 4t minus sine of 2t. So if you got it to the step before that, you're going to get most of the credit, but it would be checking if you can recognize that you can pull out negatives because of those identities. What if it would have been a cosine that would have been a negative? Then you could just kill the negative, right? As in, something does happen because the negative goes away, right? Okay. All right, let's do the next one. So which formula of the list you have there, is it? Number 3, okay, awesome. So cosine of 5 theta, cosine of 2 theta will equal 1/2. What goes in for x? 5 theta. What goes in for y? 2 theta, yep. So that'll be cosine of 5 theta plus 2 theta plus cosine of 5 theta minus 2 theta. So that's 1/2 cosine of how many theta? 7 theta plus cosine of 3 theta. What if you'd flip-flop the order? Would it matter? It shouldn't, and here's why it doesn't.
You're dealing with all cosines.
Yep, you would end up with 1/2 cosine. It'd still be 7 theta for the first one, right? The next one is going to become cosine of negative 3 theta. Does that make sense? Because you would do 2 theta minus 5 theta. But that isn't a problem because cosine's even. So therefore, this thing actually equals cosine of 3 theta. Okay? So whichever way you want, it probably is easier to pick x to be the bigger angle. Then you wouldn't even have to know that step. Although you should know it because you've got to know it. Okay, let's do this. Let's use this to figure out like one example. We're just going to do one example too because we just lack time, and I think if you can do one, you can do A, you can do B. So you've got sine times sine, and instead we just have specific values for x and y. So which formula do we use? The second one. Yep. So use formula number 2. This will equal 1/2 cosine of 105 degrees minus 15 degrees minus cosine of 105 degrees plus 15 degrees.
So why do we use cosine instead of sine?
Look at what the formula says for number 2. So I've got sine times sine.
Sorry.
Okay, it's okay. Yep. So that's 1/2 cosine of 90 minus cosine of 120. And this is only helpful if the things that these subtract to and add up to are actually on your unit circle. But in this case, they both are, right? So at 90, that's this angle, right? Which has coordinates 0, 1, right? What is the cosine at that angle?
0.
0. So 1/2 times 0 minus 120 is 30 degrees past that, and that has coordinates negative 1/2 positive root 3 over 2, correct? Is that okay? So that will be
-1.
And the double negative does matter, so be careful. Makes a positive. You've got 1/2 times 1/2, which is 1/4. So, yeah, not too bad, right? Okay, so those were product to sum. These next ones, they do the opposite thing. They take a sum and they, oh, we're going to skip one. They take a sum and they make it a product. So, fix them all. Okay, I'll just show you where one of them comes from. So we have sine x cosine y. That's 1/2 sine of x plus y plus sine of x minus y. That's formula number 1 from the previous page. What we're going to do is we're going to do a clever thing. We're going to replace x by x plus y over 2, and we're going to replace y by x minus y over 2. I wouldn't expect you to come up with this on your own. I just want you to be able to do it if I told you what to do. You'll be able to use this trick for all of them, okay? But we're just going to use it for the first one. So that makes this into sine of x plus y over 2 cosine x minus y over 2. That will equal 1/2 sine x plus y over 2 plus x minus y over 2 plus sine x plus y over 2 minus x minus y over 2. Gesundheit. So what's the first thing that you can do with that, say, 1/2? Which we'll put a 2 over here. Okay. And on the right, what happens when you add that stuff in the first fraction? What cancels? Doesn't cancel completely. The y's cancel. Does that make sense? You get 2x over 2, which is just x, right? In this next one, when that negative distributes, you get negative x plus y, right? What happens in that one? Who cancels there? The x is doing, you just get sine of 2y over 2, right? And that's just equal to sine x plus sine y, right?
Why did the y?
Because y plus negative y is no y. So when you add these fractions, they already have a common denominator, right?
Yeah.
So x plus x is 2x, positive y plus negative y is no y. Okay, let's just do example 3a. You ready? I still have a minute. I can totally use it. Okay, sine of 7 theta minus sine of 3 theta. Which of the formulas listed above should you? Second one. Okay, so this will equal 2 cosine of x plus y, so that's 7 theta plus 3 theta over 2 sine of x minus y, 7 theta minus 3 theta over 2. So that's 2 cosine of 10 theta over 2, right? Sine of 4 theta over 2. So can you simplify those a little bit more? 5 theta, 2 theta. I'm going to do one more. I'm just going to do example B, just to finish off 3. So the point is just use those formulas, find the right one, plug in x and y. Which formula is the right one for part B? 3. Okay, so do that. Plug the stuff into formula number 3.
It's like they choose T just so that we can mess up our
That's not intentional. T often stands for time. So this will be 3t plus t over 2 cosine 3t minus t over 2. If you make your t's have curly ends and make your pluses very straight, it won't be an issue. 2 cosine 4t over 2 cosine 2t over 2, which is 2 cosine 2t cosine t. The main point is that these formulas do the opposite of what the previous ones did, right? The previous ones took products, made them sums. This just goes backwards and undoes that. I think because of lack of time, I might hold off on example 4 until the end of class tomorrow, because I'm not sure if I'll have time to do it. It's the same idea, you just plug in actual angles and numbers instead. Does that make sense? So it's not really that different.